kinematics. Like I have stated earlier when I was introducing this topic, kinematics is just the study of motion of bodies without considering the force. Kinematics is a branch of mechanics, so we're not going to talk about mechanics, so let us just concentrate on this, and that is the example. The displacement s meters of a moving particle from a point O after t seconds is given by s is equal to t cubed minus 5t squared plus 3t plus 10. Find s when t is equal to 2. You realize now we are not going to use y's and x that we are used to. We are going to use other symbols. Our function here in this case, our function here is s is equal to t cubed minus 5t squared plus 3t plus 10. So that is our function, original function. What we are asked is to find s when t is equal to 2. In other words, we are just going to substitute. This one is simple. We're just going to substitute the value of t, the value of t with the 2. So just a simple substitution, like us can see. S is equal to 2 cubed minus 5, 2 squared plus 3, 2, 3 times 2 plus 10. So where we have t, we use 2 instead, and the displacement is 4 meters. For those students or for those who really do like physics, maybe I can try to give you some little bit of insights. Get to know that displacement is a vector quantity, and displacement is distance, but in a defined direction. So s is displacement, and the units are in meters, 4 meters. Now, let us now go to the next part of this particular question. That is, determine the velocity of the particle when a t is equal to 5 seconds. This is our gradient. This is our function. We need to know this, and maybe I can try to highlight something here. I can try to talk about something here. Let me use red, my best color. So SVA is a key that I normally use. From this direction, what we do, we are differentiating. From that direction backwards, we are integrating. Now for us, SVA is the key we should use here. Now for us to get a velocity from displacement, we have to differentiate. So V, which is velocity, is equal to ds with respect to t. Our t here is our independent variable, and our s is our original function. So for us to get velocity, we have to differentiate displacement with respect to time. So s, our original function, s is equal to t cubed minus 5t squared plus 3t plus 10. How do we get the derivative? Derivative, as normal, you drop. Let me use a pen now. You drop 3 here. Okay, subtract 1. You drop 2 there. Subtract 1 there. T is the same as t per 1 minus 1, and then you're not going to drop anything because 1 times 3 is just 3, and since 10 is a constant, the derivative is going to be 0, like you can see here. You can see, look at this, Look at that, how the differentiation has taken place. So that is it. And now, simplifying it further, you come up with velocity is equal to 3t squared minus 10t plus 3. You realize that whatever we've just found is called a velocity function. The original function is the displacement function. And how do we get velocity from displacement? We do differentiate it. Now we want to get v when t is equal to 5. So we are just going to substitute 5 in the where we have t. We substitute 5, and then solving it further, you come up with 28 meters per second. So this is velocity is speed in a defined direction. Velocity is a vector quantity, and the units are in meters per second. Let's go to the next question. Find the value of t when the particle is momentarily at rest. Let me highlight this word, momentarily at rest. The particle is momentarily at rest. What is the meaning of the word momentarily at rest? Assuming that you have a stone, you are holding a stone on your hand, and then you throw it upwards. That stone, before it falls back downwards, it is going to rest a little bit upwards. And that instantaneous resting is what we call it momentarily at rest. The question can be framed this way also. Find the value of t as when the particle is instantaneously at rest. So at an instant where the particle is just at rest, that instance is what we say the particle is at rest. Now, maybe now you have understood what we mean by momentarily at rest. When the particle is momentarily at rest, that means it is not in motion. And when the particle is not in motion, then we say the velocity must be equal to 0. The velocity of that particular function must be equal to 0. Any particle that is not in motion, if you are just seated there, the velocity is of yourself is 0. You're not moving. So when it is at rest, the velocity is 0. So now that we've already found the velocity function in the previous computations, we're just going to equate this with the 0. So 0, going to say this equation is equal to 0. Now we want to get t. And you see, it boils down to a quadratic equation. Using the quadratic formula, you get two values of t's. T is equal to 3.610 seconds, or t is equal to negative 0.2770 seconds. So that is how we get t when the particle is momentarily at rest. The last part of this problem is find the time when the velocity of the particle is maximum. Velocity, how is velocity, when is velocity maximum? When is velocity maximum? Velocity is maximum when acceleration is equal to 0. When the acceleration is equal to 0, the velocity is maximum. What is acceleration? For the benefit of the physicists who are watching, acceleration is the rate of change of velocity with the time. So the change in velocity with the time, that is acceleration. Now, how do we get acceleration? Acceleration is a derivative of a velocity function. Now here we are going to differentiate the velocity. We are going to differentiate the velocity so that the dv over dt with respect to t, because t here is the independent variable. I mean, it is the varying factor. So we've already gotten v from our previous computation. It's just a matter of differentiating this now. You see, now it becomes simpler and simpler. The equation originally was bigger, so it is simplified as we get along with our differentiating with our differentiating procedures. So drop this 2 here, 2 minus 1, then this t is the same as t power 1, subtract 1, and then this will be just 0. Okay, like you can see here, 2 times 3, now it simplifies to a is equal to 6t minus 10. So this is acceleration. Acceleration, for you to get acceleration, differentiate the velocity function. So if a is equal to 0, like we have noted here, acceleration is equal to 0, we are going to equate this equation with 0. We are going to equate the equation with 0, equate it with 0. And then after equating it with 0, you come and get the value of t is equal to 3.333 seconds. That is when the acceleration is maximum. So you need to know that from SVA, displacement, you want to get velocity from displacement, you differentiate. You want to get velocity, the acceleration from velocity, you differentiate.